Hi, I'm Stephan with Papadakis Racing. We're here at our race shop in Carson, California, and today we're going to assemble the engine for my 72 Celica. The car already runs, but it's got an engine that was basically spec'd out many decades ago in like the 80s. I did go through it and made it run well, but I figured let's go and do a more modern version of this old 70s design Toyota 18RG. Let's get started assembling, and I'll show you guys all the cool parts we're going to put into it.
When I bought the Celica, it came with 2 spare engines. This is one of them, and when pulling it apart, it actually looked pretty good. It looked like it had a lot of new parts in it, but the assembly lube was all dried up and stuff was rusty. It had been sitting for, over 20 years. After getting everything all cleaned, bored out, sized, blueprinted and everything, now we had the engine that it was time to assemble. We're going to start by putting all the main bearings in. After getting all the block side main bearing halves in, I then put assembly lube on the thrust bearings. You can use engine assembly lube like I'm using. I see like thick grease, which I'm not much of a fan of. You could even just use engine oil. So I set the crankshaft in, make sure it spins a little bit. I'm not going to spin it too much because I don't want to move any of the bearing shells out of their place. All of the main caps are numbered and there's an arrow toward the front, 1 through 5 again. These already have the bearing halves installed that I did earlier. Again, with the assembly lube, I spread it around and then put the caps on. This engine has a 360-degree thrust bearing, actually 2 180-degree thrust bearings on each side. It has a little key slot that lines it up, and that's on the center main bearing, the number 3. The main studs are from ARP, and a lot of the hardware, is so old in these engines, you try to replace as much hardware as you can. Over the years, I've changed my building habits a little bit. So nowadays what I do is I actually take all of the washers that go under the main stud nuts and I'll clean it and make sure that there's no lube or anything between the washer and the main cap. And then to try to be a little bit less messy, I'll take the brush with the assembly lube and put it inside on the thread and then where the nut flange meets the washer. I'll just torque that down to a minimum torque, and then this is torqued into 3 steps. And because the main studs are so large on this, the main torque is actually 80 foot-pounds. After getting it all torqued down, give it a little spin, make sure there's no binding, no issues. On the left is the factory piston and rod, and you can see the huge difference. Back in the days, in order to get the pistons to not rock and make too much noise, they had these giant skirts on them, and actually a really thick ring pack. Compared to the modern piston, which has a much shorter skirt, much lighter, and has a much smaller ring pack. So that smaller ring pack not only has less friction, but they can tend to even hold the oil and compression in better than back in the days. You can see all of the pocketing and everything that's done on this and all the lightning that CP did when they made this forged piston. It has a pretty big dome on it, but because the cylinder head has a really big chamber, that's what you need to do to get to the 11-to-1 compression. The Corolla rod is to the factory bearing spec, and it has to have that width as the crankshaft, but you can see where they took a lot of weight out of it, and the rod bearings are all coated. So this is a Clevite bearing that's been coated. The factory rod and piston is, 1,368 grams compared to the aftermarket, the Corolla rod and the CP piston. The new piston rod and everything was actually a little over 1,000 grams. I forgot to put the pin on it when I filmed this. Which is like 0.8 pounds. Like it's almost a pound lighter, the new setup. And also I'm using these Trick Total Seal rings. And what they are is it's a gas ported ring. So on the top of the top ring, it has these slots. And what happens is the combustion pressure actually is able to go into these slots behind the ring inside the land and push the ring out to help that top ring seal more. And you can get away with a little bit thinner profile ring. This is something that's trickled down from other forms of motorsport that now you can get for, our enthusiast cars. After getting the piston, the pin, and the small end of the rod all with assembly lube, I marked all of the pistons to make sure that I knew which way they were going to be installed. These piston pin clips are always a pain, but after you get the first one in or so, you get a hang of it on what you need to do. And during this part, I always like to wear safety glasses because I have had, and actually during this assembly, I did have one of these things fly across the room, but fortunately keep the room pretty clean and I was able to find it. First, the oil ring spring goes on, the expanding ring, and then the 2 oil rings go on, then the second ring, and these do have an up. And typically, like on these rings, there's a little letter that goes on the top of it, a little marking, and then the top ring, the Total Seal gas ported ring. I always feel like this is a good milestone. The milestone to where, all right, I've got the pistons on the rods, everything fit, I've got the rings ready to go in. It's kind of, should all just flow pretty well after this moment. In order to turn the crank, I'll use the factory pulley bolt, but I always put a washer behind it because I don't want to bottom out any of the threads, and then I'll impact that on. That way when I turn it, it doesn't come loose. We'll put the crankshaft pin for the rod to bottom dead center, so it's as low as possible, and I'll put assembly lube onto all of the bores, the rings, and the side skirts of the piston. After lining up all the piston rings, I then use the ARP piston installer. That's the exact same bore size as the engine bore, and if done right, it should just slide right in. Once it's installed, flip the engine over and then get the rod bolts in. All the rod bolts have assembly lube on them, and I'll do an initial torque just to seat them, about 20 foot-pounds. I'll then loosen one of them, measure the bolt length. And this is a special tool from ARP, but there's a few different companies that make these rod bolt length tools. And there's little pockets on both ends of the rod bolt, and then I'll zero the gauge. And remember, the bolt is loose, so it's just at resting length right now. And there's a spec from Corolla for their bolts on how much stretch there should be. It's about 6.5 thousandths on these particular rod bolts. So I'll torque it up, see what the stretch is. If it's not there yet, continue to torque it up until we get to that perfect amount of stretch. And then now you know that the rod bolt is installed with the right amount of tension. Everything's all calculated, so they know exactly a certain amount of stretch on that bolt with that material is going to give a certain amount of clamping force. If you just rely on the torque, it can work well, especially if you know the bolts, your assembly lube, all of that. And I typically do that. But on this engine where I've never used this particular bolt, it's a new rod and everything, I will check the stretch on every single rod bolt and make sure that they're installed within the spec. After getting the first one in, I'm rotating it, make sure nothing's hitting. And once we know all that's good, we'll go ahead and install cylinders 2 through 4. This engine has an idler shaft where, your V8 guys might be thinking it's a camshaft or something like that for an overhead valve. But it's actually a shaft that goes into the side of the block, and it runs the oil pump, the fuel pump if it had it, and the distributor. There's 2 different timing chains on this. There's a lower one that goes from the crankshaft to the idler shaft, and there's alignment marks on both of those gears and the chain. So I align that so everything can be at top dead center and set that onto the keyways into the shaft. Next, I lined up the cam chain with the other pulley that goes onto the idler shaft, and I use this little zip tie because you'll see in a little bit here when I put the cylinder head on, or actually the timing cover and everything, the timing chain would just fall into it. So this is a way of keeping it in place while we do the rest of this assembly. Installing the front main seal onto the timing cover. There's a few ways to doing this. The seal went relatively easy, so I just went around until it was flush with the front of the cover. I'll put a little bit of grease on the seal area, and then I've put some black silicone on all the mating surface, and then torque it on. Here's the oil pump, goes in from the bottom. And this is a new unit that I got. The inlet is here, and then it's got the pump section in the middle, and there's a shaft that runs all the way up, and there's a gear on that intermediate shaft, and then it's got the gear that meshes with the gear on the idler shaft, and that's what turns the oil pump. It can be a little tricky to get them lined up, but eventually got that in there, and then there's an aluminum cap that gets installed, and then that's what keeps that small gear in place, is the oil pump on the bottom, and then that cap on the top. The head gasket is multi-layer steel from a company called Kaminari out of Japan, who still makes parts for these old 18RG engines. And the head bolts are from a Nissan GTR, the VR38 engine. And it just happened to be the right length bolt for this Toyota engine. It's actually a stock Nissan part because there wasn't an aftermarket stud or anything that really worked well for this. So I've been using these particular bolts on the engine in the car. I'm using it again in this build. The cylinder head all finished up. My buddy Tom from Portflow did all the port work. The valves are a custom set. And then I used buckets and everything from Supra. It's pretty cool. This has a 38 millimeter bucket, and that bucket is the same as a BMW part that they sell. So this actually has some Supra parts that were designed for BMWs, but it worked perfect in this 18RG. And that bucket is a little bit lighter, actually a lot lighter than the factory part. The camshaft is a reground HKS camshaft. These are old camshafts from the 80s, but I have a buddy over at Kelford Cams down in New Zealand, and I sent those to them, and they put a modern grind, computer design grind on it. So hopefully, with the updated valves, springs, cam profile, we should see some additional power and not lose anything. It should just be better all the way around. The adjustable cam gears are from the same company that makes the head gasket, Kaminari, and this is the factory timing chain guide. It's kind of tricky how it works. You got to get the cam gear on, and then through this little access port, you put the guide on, and then you can put the other cam gear on. And once you get that all done, there's a little oiler that goes in, and that oiler sprays the chain, and then another guide that goes on top. I'll tighten these about that tight. The oil pan has been modified. These 18RGs have a huge issue around right-hand turns. The oil will flow away from where the pickup is. So we installed this baffle inside there. And when you go around a turn, it should keep the oil right where the pickup is. And then when you go straight and everything can settle back in, it's got this little flap. So it allows the oil to go in through the flap and keeps it in when you go around the turn. This thing's got a giant oil drain, and you can also see the bung where the oil temp sensor is going to go. So again, I'm not using any gaskets, just RTV silicone type sealant. And I put the oil pan one on really thick because it's a stamped steel pan that's not very flat. We want to make sure that we seal this up really well. In order to do that, a lot of sealant, and then you'll see it push out when you tighten everything down. After that, put a little bit more silicone and then put the cover over the access plate for the timing chain.
And then last, we're going to put on the valve cover. This is actually just going to be a temporary one because I actually want to put the red one on that's on the Celica right now. So this is it for the engine build. I hope you enjoyed it. I'm going to put the red valve cover on. I'll put the carburetors on that are currently on the car. And then we'll get the thing all broken in and on the dyno again. Thanks for watching. If you want to see more videos on the Celica that this is going into, I'll post those links in the description down below. Thanks for watching.